So in part 2, we're going to look at a function like the ones we've been seeing in this unit. We're going to look at a quadratic, and we're going to look at a factored quadratic specifically. So now I've got f of x is equal to x plus 3 x minus 7. And just like before, to find the zeros, I need to set this equal to 0. But now, maybe I don't know how to solve that yet. Maybe that's not a kind of equation that I'm comfortable solving, because I'm going to need to use something called the zero product property. And to understand the zero product property, we can play a little guessing game. I'm going to write down two numbers on a piece of paper, not tell you what they are, and then put sticky notes over each of those numbers. And I've done that right here. So you don't know what my first number is, and you don't know what my second number is, but I multiply them together, and I got 0. So pause the video, think about what do we know at least one of those numbers have to be, and then unpause when you're ready to see if your guess is correct. Okay, so are you ready to see if your guess was correct? One of the numbers has to be 0 in order for our answer to be 0, because anything multiplied by 0 is 0. My other number this time was 27, but it doesn't matter what that number is. It could have been 5, it could have been -3, it could have been the square root of pi. It doesn't matter. It would have been 0 because this one was 0. And that is called the zero product property. And the reason that's useful here is because this is a multiplication problem. Here is the first thing I am multiplying, that set of parentheses, and I'm multiplying it by that set of parentheses. So either this blob is 0, and I don't care what x minus 7 is, or this blob is 0, and I don't have to care what x plus 3 is, because one of those two blobs has to equal 0 for the whole thing to equal 0. So since that's true, I can break this in to two smaller equations that are each equal to 0 using that zero product property. So I have x plus 3 is equal to 0, and x minus 7 is equal to 0. And each of these will find a way to zero out one of the two things in my product. And this is why we care about having these in factored form, because we don't have a zero-sum property, we have a zero product property. So this is a property of multiplication. That's why we care that the whole thing is factored. So I'll start by solving this one on the left. If I make a zero pair with that 3, 3 minus 3 zeros out, and I get that x is equal to -3. Over here on the right, I would need to add 7 to zero that -7 out. So I would get that x is equal to +7. So these are the two x values, one for each of my products, that will create a 0 in this function. So here's what that means if I look at that function. If I evaluate this at f of -3, then I will get, I'll just fill in everything else in this color and then go back and do the -3. So I've filled in -3 for my x in my function, every place there's an x. Then I can do that calculation. -3 plus 3 is 0. So I get 0 in that set of parentheses. -3 minus 7 is -10. So I get -10 in that set of parentheses. Well, that's 0, so the whole thing is 0. And when I put in -3, I get out 0. Same thing will happen when I put in +7. I'm going to copy my whole thing in this color and then put in the +7 in blue, just like I did before with the 3. So now, 7 plus 3 is equal to +10. But 7 minus 7 is equal to 0. 10 minus 0, because of the zero product property, will be 0. So if I put in 7, I also get 10 out. And this tells me one of the pieces of information that I would need to graph this function. It tells me in my sketch of the graph that I will have roots, that I will have x-intercepts at -3 and at 7. So if I'm sketching that, we could put -3 about here and 7 about here. And that's roughly where my parabola will be. I haven't calculated the y-intercept yet, so I'm just going to make a guess. Oh, I didn't get it through the other point. Hey, let's get that through the other point. Okay. So a rough sketch of this parabola will include this idea. To get a better sketch, I would need to find the y-intercept, which is this point. I also knew that this needed to point up rather than point down because I was able to quickly determine the end behavior because there was no negative sign out here. Because I didn't have any sort of negative out here, I knew that this parabola would be pointing up rather than pointing down. So I was able to quickly determine that end behavior. For a more accurate graph, I'd need that y-intercept. And the reason that I knew that it would be this shape is because it's a second degree polynomial. It's a second degree polynomial because it contains 1, 2 x's. 2 x's mean it's a second degree polynomial. And this is how you can find the zeros if you have a factored second degree polynomial.